Chapter. Paul currently leads National Grid's modelling activity for system planning, but has worked over the last few decades very broadly across the company in various aspects of power systems analysis. So it's very well placed to give us a view of the mathematical modelling issues which transmission system operators and planners face. Paul.
Thank you, Chris. That was a very appropriate introduction. I'm solid electricity man. There are a host of other problems that I trust you're covering this week, but I will speak 100% for electricity because that is where I've worked for the last 30 years. I'm afraid I'm giving you some problems to you. I am not going to give you any answers at all. The nature of this talk is an overview of problems I identify. Wind power is quite exciting for an electricity system in that for 30 years we've had marginal coal-fired and gas-fired power stations, and the sorts of problems they pose have trickled on for 30 years and largely been solved. Wind power is pretty different, and if we move to a world where a large fraction of the total generation of a country is coming from wind power, then there are some very interesting new problems to address. This talk is an exact copy of the one I gave in this room 2 years ago, as per the date on the front cover. I make no apology for that. I haven't really made many progress on answering these problems. Okay, first feature I will draw up to you is who are the stakeholders? Why is anyone interested in this problem? And I think there are 4 classes of stakeholder to think about. You'll probably want to think who to approach for funding, of course. The electricity industry itself, the generating companies who own the power stations, the suppliers who have to contract for electrical energy day by day, and sell it on to us customers. The system operator of the power system, I'm mainly speaking for Great Britain today, and National Grid is the one system operator for Great Britain. The transmission owners, of whom there are an increasing number across Great Britain nowadays, and distribution systems owners. There's quite a big gap in electricity between transmission at high voltage and distribution at low voltage. Probably too big a gap. The government and the regulator is a very big class of stakeholder, and they tend to control the money and set the rules, so one has to pay attention to them. Be warned, they tend very often to have an economics frame of viewpoint rather than a mathematical viewpoint or a electrical engineering viewpoint. So getting au fait with some terms of economics is quite useful. Electricity consumers and the general public. The amazing bit about the advent of wind into the electricity industry is that at the average drinks party one goes to, the average member of the public will actually say, oh yes, I've heard of a wind farm coming up near my house. Is it true that they don't even pay back their carbon they invest over their whole lifetime? And other such rumours like that kicking around, that there is reasonable interest and some general appreciation of our problems, which was certainly not the case for the electricity industry 20 years ago. And the final stakeholder community is yourselves, academics, who have realised this is quite an interesting area, and there's also quite a bit of money in it, as you will see in later bits of my presentation. Okay, I'm going to pose 6 problems, and I'll try and rattle through them fairly quickly, I think. To some extent you can read them up on the board and see them. The problem of generation adequacy. For a collection of conventional generators, GN, a fleet of wind farms, WN, N is a suffix for your list of power stations basically. What is the probability that your conventional output plus your wind output exceeds, or probably actually is less than forecast peak demand, is the bit you're worried about, because that's when the lights go out, you have run out of power station capacity, and you should have built some more power stations. The results are, of course, hugely dependent on the correlation of wind power across the whole country. which is why when I walked in disappointingly late, the question raised was, are you trying to forecast the aggregate output for the whole of Great Britain, or the output for one wind farm, or the wind farms in one county? Those are going to be two very different results. This problem is particularly interested in the probability of near zero output, of course. At stake, how important is this problem? On top of the capital costs of 25 gigawatt of wind farm, which is about 50 billion quid of capital costs for wind farms themselves, you need some backup capacity to cope with the cases where all those wind farms give you nothing whatsoever. And the last 5 gigawatt of generation capacity, at sort of current prices for CCGTs, for typical backup capacity, is about 2 billion of capital, which I would annuitize to a bill of 300 million per annum. And we're talking of moving to about 25 gigawatts of wind across Great Britain by 2020. There will in there be 300 million per annum. That is 12 million per household of capital costs for the backup capacity. That's problem number one. Problem number two, normally a lower order problem. It's the planning of a transmission, which is actually my full-time job at the moment. And for this one, you have your same collection of conventional generators, GN, but we're now going to suffix it by zone because they are located differentially across the country. Gas-fired stations are typically on the east coast, near the North Sea gas fields, nuclear stations around the coasts, and a fleet of wind farms, which for Great Britain are typically very strongly located in Scotland, because they've got a lot more space to build wind farms in Scotland and a lot more appetite to have them. How much firm transmission capability should one construct for the sort of boundaries, the swathes of country between the various zones Z? And you'll specify the demand in each zone in gigawatts as well. With regard to the wind, you need to know now the correlation of the wind fleets between the zones. You don't just want the national total of wind. You've got to know, is the Scottish wind going 100% correlated with the English wind or not? And the time of maximum transmission requirement will actually relate to the anti-correlation. The time of biggest need for transmission capability Scotland to England will be when the wind in Scotland is blowing hard and the wind in England isn't. At stake, Great Britain transmission owners have said that the amount of onshore transmission reinforcements, this is just reinforcement spend, is 4.7 billion capital. That was a figure widely quoted 2 years ago, which is going to equate to about 500 million per annum on annual bills, an increase in annual bills by 2020, if indeed we spend all that much, and there are endless other figures of that sort floating around. Offshore transmission planning. In order to achieve targets for wind, you must know that quite a big fraction of our wind farms for this country we want to put offshore. And you then got to decide how much transmission to build offshore, which is, of course, horribly expensive. There's got to be cables along the seabed to collect a group of offshore wind farms to the onshore system. You'll need the distribution of outputs of one or more offshore wind farms, particularly focused on the hours near 100% wind farm output. And whereas a collection of wind farms onshore, for example, across the whole of Scotland, you'll have precious few hours in the year that 5,000 megawatts of wind farm scattered across Scotland will actually generate 5,000 megawatts of output. You will have 400 or 800 hours where a collection of 5,000 megawatts of wind farm offshore will generate full output. At stake, the connection of 25 gigawatt of offshore wind by 2025. That's a fairly ambitious target, but is what is officially needed to meet government targets. 30 billion of capital cost for those offshore cables, which is a socking rate bill of 3,000 million per annum. Dwarfs, interestingly, the onshore transmission cost, that was 1/6 of that I quoted previous slide. My company has said that a 25% efficiency saving can be achieved by an integrated design of that. Does presuppose you know exactly how much wind is going to get built where, but efficient designs, which of course is clever chaps such as ourselves, designing the correct level of transmission to build, have got quite an attractive saving to achieve that. Fourth problem I will pose you, interconnection planning. Great Britain is not an island in isolation. We are meeting European targets, and countries, our neighbouring countries across Europe, are all facing the same problems. Denmark has already built a huge number of wind farms and is contemplating whether it wants to build a cable across to Great Britain or not. I'm actually Chinese-walled from colleagues in National Grid who are investigating that problem. My personal opinion is, I'm afraid, that Denmark is not a country I would wish to interconnect with. I'm sure for more attractive ones. But whether my colleagues share that view or not, I don't know. My reasoning, simple. Denmark is fairly stuffed with wind. We're fairly stuffed with wind. On average, the wind will blow at the same time in the two countries, so the cable will just be sort of fighting, wind dumping from one to the other. You won't have enough occasions when it's windy in one country and not in the other. Interconnect to Germany, where the wind is more diverse. Interconnect to France, where you can diversify with nuclear. Interconnect to Norway, where you can diversify with hydro. Which is what that problem is about. At stake, an extra 5 gigawatts of interconnectors Great Britain to Europe, which is certainly the order of magnitude people are talking about. Some talk about an extra 2 gigawatt realistic by 2020. Some talk about an extra 10 gigawatt realistic by 2025. That would be about 2.5 billion capital, about 250 million per annum. A lot of money could go into connectors, and a lot of questions at the fundamental: how much money are they going to make, or how much are they going to save you? And an equal raft of ugly economist questions: who should own those interconnectors and how should they get paid? Year-round operation, there's a cluster of questions here for the system operator of a power system. What are the incremental costs due to wind of year-round operation? And there are some sub-questions relating to individual aspects of costs of year-round operation that I won't go into here. In the last 2 years, we've got a bit more worried on the last bullet. The problems at low load may be rather bigger than we have thought, and it is going to be interesting for someone like me to watch whether National Grid comes clean on this in public by its publication of what will be called the second electricity 10-year statement at the end of this year. There are some people within National Grid pretty worried by the low load problems, particularly out by 2030. As a specific example of that, the holding of reserve, and this is where I'll get towards what for me is a very short-term question. For a given forecast of wind output from your wind fleet WN at 4 hours or 8 hours or 12 hours ahead, what is the distribution of wind forecast error such that how much reserve should one hold on other generation or other demand sources of reserve if you're lucky enough to have them, such that the target we work to is you run out of reserve on one occasion per annum. That is the statistical measure we try to use for that. You'll need to convolve your wind forecast error with errors in conventional generation and errors in demand forecast. My colleagues sitting down in that area of the room know far more about this problem than me. At stake, National Grid has said in public that it expects an on-cost of 200 or 300 million per annum by 2020 due to this. Be warned, there are very many other estimates of this on-cost kicking around, including detractors of wind who say that the sort of on-cost of reserve holding dominates the actual cost savings of the wind farm itself, which of course is not true. Okay, those are 6 problems which I have posed 2 years ago. There has been some progress on solving them, and across this week you will discern fragments of progress. One distressing feature is that quite a few solutions are not public, and people pay for their own research and don't make it generally available. An advantage of a seminar like this is that everything is public, and it is much easier for us all if data is public. My dream team to solve these problems, I scatter this thought across you, has got 4 sorts of individual on the team. A meteorologist to characterise the weather conditions, a geographer or turbine engineer, arguably 2 different skills there, to perform the conversion of wind speed from ground level to hub height and thereafter to actual turbine output. Hopefully some of you are familiar with the problems involved in that lot. A mathematician statistician to aggregate all the individual wind fleet outputs and keep track of all the correlations, both temporal and locational, you've got in the answers to 1 to 2 above. And finally, I'll give a role for sort of myself to interpret what the above means for the power system and try and keep it on the straight and the narrow of what I regard as useful outputs, which is what happens to my beloved power system. But there may be many other interests kicking around, not least the wind fleet owner as to how much profit he can get from me, the power system owner and operator. I put it to you that even in this august building here, there is no one present in this room who can claim to be a master of all 4 disciplines and hence solve any of my problems single-handed. You are going to have to work collaboratively to produce a decent answer, at which point I will stop fairly early and gain you some time.
Thank you, Paul. Questions?
Paul, a simple question. So you have unashamedly admitted that this is 2-year-old presentation. So to what extent have the numbers changed from 2 years ago to now?
The actual numbers, I could flick back through and chatter a bit on that. The generation adequacy costs are being explored under energy market reform, and I'm not up to date with the latest numbers that are about to trickle out. In the last 2 years, our regulator for this country, Ofgem, came out and said he perceives a 1 in 12 chance that we will run out of power stations for winter 2015-16, which is a very precise estimate, far more precise than anyone else has come up before. A gentleman standing alongside me in the room knows an awful lot more about this number than probably anyone else in the country. So that number has got more accurate, but in one stream of studies, but hasn't essentially changed. Numbers here, there have been other estimates of the total cost of transmission, and I won't confuse you with them, but there's no single answer for the cost of GB transmission.
Have they gone up or down?
Up a bit by including some extra projects. Prices, I think the price of transmission has stayed reasonably the same over the last 2 years. The price of transmission did approximately double over the previous 10 years, from 2002 to 2010, which is fairly disturbing for us. A change of a factor 2 in your prices, as you know from your own sort of cost of living, does upset your budgets and upset things. Largely due to the price of copper itself going up. This price here, I don't think offshore transmission has changed in price by a huge amount over the last 2 years. The volume of offshore wind has slightly gone down. I think I'd pluck a number of 20 gigawatts by 2025 out of the area rather than 25 gigawatts if I was asked you today. Interconnector planning, no greater insight on that, either on the price or the number of interconnectors. It's a very loose subject. Year-round operation, I was not brave enough to put any numbers to that one. National Grid isn't, and the costs of reserve we have not revised since making that estimate 2 years ago. Whether we should have done or not, I know of no particular driver to get there. So, have numbers changed? Not hugely. One extra bit I did want to say and slip in, which I will do, Most of the time in electricity, costs do stay fairly stable. A change of 50% of prices over 10 years is typical evolution, and you can live with it. There is one particular area of electricity technology where we have had a revolution, not an evolution. The capital cost of solar panels to install solar generation between about end 2009 and end 2011, anywhere across Europe, Germany, Italy, Britain, the cost of solar panels halved. And thus the subsidy needed to persuade people to put up solar panels was retrospectively changed from 40 pence, say, in kilowatt hour to 20 pence a kilowatt hour. But a halving of the capital cost of a source of generation is revolutionary. In consequence, Germany has now installed 30 gigawatts of solar power, which on about an 80 gigawatt power system is colossal. Germany is now exporting solar power whenever it's sunny, even probably today. And of course it has to take power in the morning and the evening when the solar is not generating. That is a revolution. And so the wise do have to watch out for revolutions of capital cost. They happen extremely rarely. It's the first time, I think, in my working career I will acknowledge a revolution of capital cost of that sort.
Presumably Germany can only get away with that much solar power because they buffer it against the countries to which they export. You couldn't cope with that in a single country.
No. If we suddenly built 10 gigawatts of solar power per annum in this country for 2 years in a row, our power system would be in grave danger of sitting down, and National Grid would be muttering about inoperable and invoking emergency conditions and generally becoming extremely unpopular. Germany is, of course, pretty heavily interconnected. Its neighbours do grumble, but they haven't actually taken the ultimate action, which, if Germany goes too gung-ho happy, they will open their breakers and say we refuse to interconnect with Germany, and we will sever our connections with Germany, as, of course, ultimately you're always entitled to do.
I just have a quick question, because you mentioned this point that people kind of hide their methods and results, and maybe it would be better to be going public and share a bit more. Are there initiatives at National Grid to share more data, share methods, experience?
Afraid not. I am not senior enough in National Grid to influence this debate, and like everyone else, National Grid, when it's got some data of its own that it feels is strongly to its advantage, it will shoulder it and keep it in. Gradually the regulations are catching up with us. At the pressure of the likes of you, we get obligations to make data public, and we are slightly better at that than we were 10 years ago, but not a whole lot better.
Yeah, so just picking up on that, is it failure here? One of the things that's very common in mathematical and statistical sciences is that people actually, challenge each other, level up, share data, do all the things that have just been suggested. But in some sense, National Grid's quite a sort of special player in the nation. Why don't you engage with research councils, engage with the communities? Why aren't you forced to make this sort of data available, since this is ultimately a large amount of cost on the UK, either the consumer or the government? It's ridiculous, surely, that you can hold back data and not release it to a community that's showing interest. You should get yourselves aligned with the research councils and sort it out. And if there are people more senior than you that don't hear that, then someone ought to pop along and see them.
I'll give two answers to that. Information is power, so the natural incentive on an organisation is to protect its own information and to protect its power. The value of the quality that of results that you get by the dialogue is less than the native value of the research in the first place. So the incentives are poorly set, and they are poorly set whether you're in public or private ownership. The second flaw I get to is, you're right, so of itself, National Grid will not typically naturally volunteer to be particularly helpful on this. My senior managers probably wouldn't be too happy with me for raising the issue this candidly here. Tough, and that's what I come along here for, to cause trouble. But what you need is the politicians to realise the value of information and to enforce publication not only of the data but the information. And it takes a huge level of understanding of a fairly senior politician to realise that this is something useful to put in place and therefore to enhance the regulations to do it. To quote one example, the actual megawatt hour output of every power station in Great Britain is a matter of fact. It is recorded in a huge number of places for various purposes. The obligation on Elexon is to publish that data, but they only have the obligation to publish the data. And hence on the Elexon website you can download 300 power stations times 17,000 half hours across the year, which doesn't fit into at least my 2003 Excel, either on the number of rows or the number of columns. What the regulator should have spotted, and has failed to spot for the last 10 years, that is data, an appalling volume of stuff. Most people actually know some information, which means obligation to summate that by fuel type, by company, by zone, and summate it at the weekly or the monthly level, such that you can get it onto a normal size spreadsheet and use it for macro estimates and do some sums with it. But that requires wit to realise the regulation, not just you've got to make the half-hourly megawatt hours by station available, but you've also got to do some post-processing and add it up for everyone in a useful way.
Well, that's acceptable in terms of there's obviously need for metadata and information to explain what's in the lower level. I don't think we need to take the spreadsheet as being the unit of desired. Look, there are other sectors in this country who have been forced to share data, from ordnance survey maps through to a number of others, through initiatives like the government Big Data Initiative, just spending a very large capital investment and shortly to put money into development of maths and stats to deal with it. There's a My Data Initiative from BIS, where there are strong regulators are going to force all sorts of regulated areas to release raw data. I don't think it will go as far as the supermarkets, but it certainly might include mobile phone data and that kind of thing. This has got ahead of steam for the last 3 or 4 years with Tim Berners-Lee and others pushing for it. And I think that your company would be better to accept this as the direction of travel and get on with it.
Well,
and size isn't the issue. You shouldn't simply be saying, well, there's an awful lot of it and therefore it's useless. Actually, there are lots of sectors where very large amounts of data are analysed in real time, at pace, and I think you're just holding this up by not releasing the data.
Well, it depends whether we volunteer to release or whether someone forces us to. On the particular issue, if I can ask Andrew Richards, who probably knows, wind power output by half hour by wind farm. I mean, we've got our own data set.
Not allowed to release it because the individual wind farms consider it to be commercially sensitive.
Yeah, and I will echo your word across to my Wokian colleague and say ridiculous. But that's the way the rules have been drawn up. On the previous slide here, I used to manage parts of this process, and every contract, ancillary contract we've got for services to do those things, they have been confidential ever since the contracts were conceived in 1990. And I think the industry is 5 years behind where it could be because no one's had the wit to pick up. Hold on, make it a requirement in the licenses, make it a requirement of a transmission license or generation license that those contracts are publicly available. And they'll all be sitting there on a website. It'd be immensely tedious to read, but because they're public, then there will be no secrets hidden. Costs might go up by 5% in the first year as people felt they were losing a commercial edge, but that would be an overhead worth paying.
Paul, your presentation was most about economics, how much you can save, or how much does it cost the whole business. And going back to your dream team, to what extent you could reduce those costs by each of your individual member of the dream team, and especially mathematician, statistician, because that's what we are here for. Is there a scope for saving? I mean, if all the brightest mathematicians in the land put their effort into it, to what extent they would be able to reduce those costs?
That's a good estimate to ask me, because yes, I've only said the total amount of money, and of course how much you can save, the fraction will vary according to sort of how rich the problem is and how many diverse solutions are. The only hint I gave was that number from offshore planning of the number of 25% National Grid has put out. Of the relative fractions, I don't know exactly what proportion is up for saving. Sometimes in these problems you can achieve savings of 5–10%. Sometimes you can only achieve savings of 0.2 or 0.5% of the total cost. When the costs are in the multi-billions, even a saving of 0.5% is well worth grabbing and pays quite a few salaries. The relative contributions to the general problems of these four
I don't think, Paul, that the answer to the question that you can really break it down between individuals, because as you said, no one bit of the team is going to solve it. So
yeah,
it's a collaborative effort.
Well, but let me. I always like trying to estimate stuff like this. I think So let me think of dream teams I've seen of. Would be missing one element. If you're missing the power system engineer, you can probably actually got a fair chance of going through without. I'll pretend that I'm the least valuable of the four in the team. May not be true, because why would the other three bother to get together and talk to each other? I'm afraid I think I would rank them in the order 1, 2, 3 they come there. I think the meteorology is pretty important in this, and there are insights on the understanding of weather and what's going on, and if you don't start off with that, you're not going to get too far on this. The geographer turbine engineer, I've seen some spectacular errors made by people who've ignored that. For example, forget to translate wind speeds from ground level height to hub height. A nice factor, 30% error can come into analysis from that single bit alone. Mathematician, statistician, it's sort of, he's the tool, he's got the tools, so he's not contributing anything direct in there, but he's the glue that keeps them together. So it's difficult to see the value of the statistician directly. I would not like to quantify it. I've dug myself into a pit already, and I'm going to get booed off the floor very soon. Stan probably gave the better answer. No, the point of a team is that it's a team answer.
But generally, what's the percentage saving of the whole team? How much can you shave off the costs?
Varies by problem, between 1% and 5%.
Okay, meteorologist.
Okay. Yeah, I'm very pleased to be on. But one comment on the team there. There's no mention of the economist and the markets part of this. Can you comment on that? Or what, is there a deliberate reason why you've left them out?
Probably wish fulfillment by me, but I dislike my regulator, and so I dislike economists and what they bring to it. Despite the fact I've had to become one, or at least pretend to be one, for 15 years. For wind modelling per se, you can pose the abstract questions in the manner in which I posed them, and hence answer them without market insight. If you're actually trying to justify a pound note answer, the answer will depend on the markets, and therefore you may well want an economist in the team. And there is the sort of meta question: if we designed the markets differently, would you get a different answer? And that question is actually very important. No pound note estimate is absolute and comes from the fundamental physics, mathematics, geography of what's going on. It all depends on the market rules, which is very uncomfortable for the rest of us. And in that sense, an economist is a necessary part of it. And since he defines what a pound note is, he's going to have the most important contribution.
Just a quick comment on that. My experience over the last, 10 years is that this dream team is great, especially if they are all good academics, but the economist is needed for showing the value of all the work done by the others. Because I think all these guys up there have been quite weak at showing what's the final value of all the research they are doing. So it might be there also that the economist has a part in the team. No?
Quite possibly. One observation I'll make is I've joined a few European working groups, and I've been very impressed by the level of economics speak of a typical electricity industry man who comes up from a European university. European universities are rather better at giving the basic training in economics than British universities. How many of you are comfortable with the concept of the rent extracted by one player in a sector? If we talk about the rents that a power station owner can get in energy markets, that sort of confess, are you comfortable with the term? Are you got a vague idea what it means? Have you not got a clue what I'm talking about? In Britain, I would expect the proportion to be a third, a third, a third. In Europe, I think the proportion would be 2/3, 1/3 north.
Yes, I would like to ask, how can we calculate with it? It was the 0.6. So how can we calculate with the possibility of reserving or buffering the wind energy of some manner? Maybe it's under development, but maybe it can improve the forecasting of some manner.
Sorry, please repeat the question.
Okay, I repeat it. So, in holding of reserve, can we finally aid the result of the forecastings in the future with the reservation of some wind energy?
The typical measure you use for forecasting reserve is the error of forecast 4 hours ahead, either as a percentage of your total demand, or ultimately it's got to be in absolute megawatts. And then the price of reserve feeds into the value of the answer. But the metric of standard deviation of reserve forecast is a standard metric and a useful metric. I don't think that's your question.
That's I repeat, because here I see that reserve now it could be come from a source of, for example, conventional plants, power plants, no? Or like
a number of different plants can offer reserves, and there are various qualities of reserve. Europe has just about defined what it means by primary reserve, secondary reserve, tertiary reserve, which and the European definitions don't agree with the previous British understanding of 10 years ago. That lot gets all rather complicated and messy, and I wouldn't want to expose all of you to all of that lot, unless I had to.
And this method can be sustained also if this wind energy capacity will be greater, much greater, for example, 3 or
our National Grid's 2020 operation document extended the reserve problem out to a hypothetical year 2020 to see what the size of the problem would be. And the broad result, not articulated desperately clearly, but sort of visible if you can read between it, average reserve levels double, and at the time of fairly heavy wind, the reserve level triples. We normally hold about 3,000 megawatts of 4 hour ahead reserve, and that had a peak at 8,000 or 9,000 megawatt in the study studied.
I don't think we have any geographers or turbine engineers in the room.
Oh, dear.
There was one piece of bait that Paul was trying to make me rise to a bit about the one in N. I've got to make my usual caveat that anything I say here is the views of Chris Dent, the independent academic, rather than Chris Dent, who was contracted by National Grid and Ofgem to work on the capacity assessment study. But I think there was the famous quote from I can't remember who that predictions are difficult, especially predictions about the future. And I think this is what we're dealing with a lot of the questions in policy debates like that. But there are some once you start looking some years ahead, there are some things which are simply very uncertain, and there's not really a sort of ingrained culture of acknowledging these futurology uncertainties in these debates?
Well, the joy of being a statistician, yes, I forecast that there was a 1 in 12 chance of failure. The lights did fail that year. Yeah, my forecast of 1 in 12 was still correct. The fact that it actually happened is neither proof nor disproof. In this room, luckily...
In a row.
Yeah. Well, I mean, there are whole bits of sort of almost human perception. When things go wrong, do people really understand it? At least in this room, we understand, almost all of us, I trust, what a 1 in 12 failure rate means and what the interpretation is. Something I do notice is that once something happens once, people forgive you. Once something happens twice, people don't forgive you.
Yes.
Think of the rail industry about year 2000. They had 2 or 3 big train crashes. And they were sort of individual inquiries and separate reasons, but once the second rail inquiry heard, really sort of a consensus in the country, rail isn't as safe as we thought. Whether a few of us even didn't travel on railways, I doubt, not many of us, but we realised that we're going to have to spend more money on our railways. We need to up the reliability standard of railways. And that wasn't very exact, it was just the human result. Something has gone wrong twice, that is pretty bad.
Yeah, I mean, speaking also as someone who's got nothing to do with National Grid, of course, or capacity adequacy study, as this process filters up to the people who read the final reports and take the decisions, all the sensitivity, the errors, and all the uncertainties get lost because people take best estimates. They like point estimates. So at the end of the day, we come up with a probability of 1 in 12, which is a sort of point estimate, but it's quite possible that it'll happen 5 years in a row, despite that probability, because the background climate to what we consume or what the industry produces changes, or the assumptions are slightly different from those that tune into the models. It's all very hairy, and I don't think that the people who take the final decisions really understand that.
I refer I'm a forecaster. When my forecasts are wrong, I mentally categorise my errors into 3 forms. Type 1, things within my model I didn't quite estimate right, and I should have got them better. So that was a sort of internal model error. Type 2, the external world changed, and it wasn't particularly reasonable for me to have foreseen that. And so I'm sort of unlucky that the ground moved under my feet. Type 3 error, I just didn't understand the process in the first place, and I was way out because I didn't understand what was going on at all. I don't think that's the same as the classic statistics, type 1, type 2 errors, but it's akin to that, and it's worth bearing in mind throughout your career. If you're honest enough to review your performance and say, did I get my forecast right or wrong? Are your reasons within your control, outside your control, or just you're totally incompetent and shouldn't be in the job in the first place? And I have known a number of organisations make type 3 errors.
We hope not for that. There are lots of things that have to be guessed about the future. Quite apart from statistical variability in the sense of something that goes wrong from one way one day and the other way the next day.
I mean, luckily with wind, the underlying fundamental errors due to wind and variability due to the wind can dwarf your internal model errors. And so you may be able, in this subject, to get away with a whole load of errors because the problem generally is very uncertain in the first place.
Any last very quick points before we have a tea break? Okay, so should we thank Paul again?